Raise the roof. So, what is an array?
The list separated by commas.
It's an object.
Not anymore, but it is. It isn't, but it is. Sort of. So it's a comma-separated list. Okay, it's a list of objects.
Elements.
It's a string now, isn't it?
Strings are arrays. Fun
Oh,
fact.
What?
Yeah.
that's right.
Yeah.
But an array of objects is a string of objects?
No. An array by itself is really, it's a list of the same type of thing. Right? So
Separated by commas.
Separated by commas, that's just how it's displayed.
Alright.
They're technically in different places in memory, but
Okay.
that's a different conversation.
Okay.
But to us, it's a comma-separated list of values that are the same type, right?
Yeah.
If I had to list all your student names, that's going to be an array of strings.
Right.
If I want to list all your student data, that's going to be a list of objects, right? So in JavaScript, arrays were denoted by the square brackets, right? Same thing here. So if I wanted to say, you know what, var names equals new string array, there we go. I get an error. Because of course it can't be that easy, right? It can't be that easy.
Is
Oh.
string supposed to be capitalized?
No.
Okay.
Doesn't matter.
You
It
put-
doesn't.
you-
Because capital S string and lowercase s string mean the same thing.
Okay.
Generally, whenever I'm doing the type string, I tend to do lowercase. If I'm doing any methods on it, like string.join or something like that, I do the capital S string.
Okay.
Because conventions.
Sure.
But our error here, if we hover over it and check it out, can someone read that for me?
Array creation must have array size or array initializer.
Yeah. So what is that? So can you put that in English for me?
What that means is that you have to declare the size of your array
Yep.
when you create it.
Yes.
And it's limited, so you
Yes.
can't just upload whatever you want.
Well, that's.
Why?
Right.
Yeah.
So there's a lot of stuff going on
Likes
here.
that.
Right? That jarred a lot of people, right? They're like, whoa, wait a minute. In JavaScript, I can just kind of expand and despan my array willy-nilly. It doesn't matter. Here we go.
Right, because it's a list, and like the function of a list is to add or take things away from it.
Right. Arrays, remember how yesterday we said C# is closer to the middle? Arrays are, computer science talk here, technically just blocks of memory that we're saying here we are. I'm reserving these 5 buckets
Oh, so-
for something in here.
okay. So
So
that's
it's-
why you have to tell it.
Yeah. So I'm saying, you know what? My array is always going to be 11 people big because I have 11 students.
So does this mean that, like, in JavaScript, you could fill up an array to the point where you lose the memory and then just crash because of that?
Yes, but not for the reasons you're thinking of. So if you haven't noticed, arrays in JavaScript are actually just objects with numerical keys, with a couple of extra things around them. So like objects and arrays are pretty much treated the same. I know, it's weird. JavaScript's, it's all kind of blurry and all just kind of works. Oh, you're fine. You're fine. Oh, okay. I could have blown it up for you.
No, that's not gonna help.
Oh, okay. Alan?
Do you understand?
So string refers to what type of
Yep.
stuff is in the array?
Yep. So I'm saying, you know what? Names is an array of strings. Names, exact same thing. Names 0 equals B. Names 1 equals Joe.
Wait, why are you doing it like that?
You have to define it.
You can't just do new string and then inside of that array do that?
I could. We'll get there in a second.
Okay.
So this is how we would assign it. Looks very familiar, right?
Mm-hmm.
There is a shorter hand to do it. I can say, you know what? New string of 11 or new string that contains B, Joe, Liv, Hector, and so forth.
And the rest are empty?
So here, I only did 4 here whenever I sized it up. So now my array is only 4 big. So I can't dynamically and shrink it or grow it. If I wanted to make this a bigger array, I'd have to renew it up and say, you know what, now it's actually length plus 1 or length plus 2 or something like that. So it's a very manual process. Amanda?
Why isn't the objects that exist in that array inside the square bracket notation of new string?
That's just a syntax for initializing data.
Okay.
So we don't put the amount in that
Nope.
new string?
Nope.
Empty array, I guess.
It's one or the other.
So if you just put a number, you didn't assign anything, you could just assign
Yeah,
as it went
I can
along.
assign it later.
Okay.
So like, I'll go back to this. Names 0 equals B.
I see.
Same thing. Yes, Amanda.
Yeah, so you can't just like names without an index because it's holding a specific place and then we're going to tell where it goes, right?
So like, could I do like names equals something here?
Yeah.
I could, but it's actually expecting it has to be an array. So I could reallocate it to be a new sized array.
Okay.
Names refers to the bucket, just like how it referred to the actual array structure, not the individual values. But here I'm actually losing what was inside of it.
Why
New. So be in the will.
why can't you simply just add one to your why do you have to do the new string? Why can't you just increase the number?
That's how because arrays are very restricted.
I mean it's doing what you tell it to do,
It is,
essentially.
but if we wanted to add one to here, what it's going to do under the hood is going to actually like try to expand that, and it doesn't know what's here. So we have to tell it to expand it.
So it's like concatenating,
Yeah,
but
it's
not.
it's doing a lot of low level stuff that we don't care about, and in 5 minutes all this pain will go away. Well,
Could you, because it's restricted, but you can declare the size,
Mhm.
could you use a variable to declare the size?
yeah. So if we had like a
Ask for
var
an input, right?
yes var student count equals 11, and then I want to make student count arrays.
So if I'm importing from an API, I can do a count of all the data first that I need to store, put that in a variable, and then put that variable inside that string, and I would have the right size array.
Then you could change that, the student count, and that's okay?
Yeah, if I do this, it's going to increment student count, but it's not going to change the size of the array. Once I make that array of a certain size, that's it.
So now student count is just rotating through the 11 items you have in that array.
Say that again.
So then student count is iterating through the 11 items that you have in that array.
No, I'm using student count to define how big it is. That's like saying that I'm defining how tall a basketball hoop is. It's 10 feet tall.
So it's adding to the array.
It's saying what size it is.
Student count plus plus is just adding, now student count is 12.
Yeah.
But the array is still 11,
Mm-hmm.
because you're not targeting the actual array.
So it's the
Yeah.
same thing as adding new string 12, just,
No.
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 What if line
It's two
28 was
two
at line
separate-
26?
okay.
We're saying, you know what? Oh, I have a number that I want to use. I'm going to use that to do something. But then I'm going to modify this number over here. I'm not touching this. Even though I use this to create the number, I'm not actually changing this.
So you're adding, but you're not adding.
Yeah. So let's say that you're painting your room, all right? What's your favorite color?
I don't know.
Purple, great.
Yeah.
So let's say I'd say I want to paint my room my favorite color. Today it's purple. So I'm going, okay, purple, painting my room. But tomorrow, my favorite color is now green. My room is still purple. Even though I've changed my favorite color, my room is still painted green. I haven't done anything with that, so it's two separate things.
Okay.
Here, exact same idea. We have a student count that we're using to compute something, the size of the array, but we're changing this over here. So even though this is changing, it's not affecting what we computed it from.
Sure.
So, Alan Don Factor.
So, let's say you wanted to add another student to the array. You would have to increase the value of what is in the array, then you have to update the array and then add the new person.
Yeah, you'd have to change the size of the array, copy over all the old values, and then assign that new array to the value of the old array.
That's not what student count.
No, it's not. I know, right? This is crazy.
Actually, this is the first time you taught something that actually made me angry.
Yeah, right? Arrays are very constricting. They're very like, what is this going on, right? So, Dawn?
So setting it, making student count a variable probably isn't the best idea then.
See, it doesn't make it. Yeah.
It's either way you have to redo it.
Yep. Hector, he's been waiting patiently.
Don't pass it on.
Okay. B and then Will, or Will then B?
It doesn't matter.
B goes first.
So, is this an instance where something is you're teaching us the more difficult thing and then you're going to change it?
Mhm.
Okay.
He just said that. He said wait 5 minutes.
It really is.
We'll play
Please
B.
wait 5 minutes and the pain would go away.
Yeah, it will go away. Because arrays have all these rules, restrictions. We can't change it even though we can change how big it is. It's like, what is this thing, right? Well, actually, pain is actually good in some cases. But, really, we're going to use something called a list for a lot of things. Because arrays in C#, as well as a lot of other backend languages, are just the tip of the iceberg. Right? Because actually, if I say, hey, I have a collection of things that does something, that has a similar type, that has actions on it, that's a really big requirement. So this is where we're going to take our first real steps in something called an IEnumerable. Whew. Right?
IEnumerable?
IEnumerable.
IEnumerable.
Yes, IEnumerable. Enumerable.
Enumerate.
Yes. An IEnumerable is a fancy term for a list. It's a very generic list. It's kind of like the parent of all list classes inside of C#. So an array is an IEnumerable. But really, something that's a bit more closer to the arrays in JavaScript that we're used to is something called a list. Lists are in a namespace called systems.collections.generic. Whenever I add that, now I have a list of type strings. That's what goes inside the alligators. And now, you notice I didn't define a size. I didn't define anything that kind of we took for granted in JavaScript. This acts like a dynamic array. This acts like the array that we have inside of JavaScript. We can add stuff to it, we can remove stuff, it dynamically shrinks, grows. This is what we should be using. Does that feel better?
A lot.
Yeah. Tension relief. Amanda, and then Hector.
Why doesn't this require a specific amount of space and memory, the way arrays require a specific amount of space and memory?
This is
Allocated
storing data in a different way. At a high level, it's a linked list.
Okay.
Alright, so you're creating links every
Yeah,
time you add something.
So, quick computer science data structure talk. So, right, this is actually the fun part. So arrays that we set in memory are just chunks, pretty much just, side by side, right? It's like a row of houses. Like they're side by side by side by side by side. But really, a linked list, everywhere where we store something, we're actually storing two things. We're storing the value, and we're also storing where the next thing is stored.
Mhm.
So everything gets that. So these aren't guaranteed to be next to each other. These are blocks. These are buckets.
What did you write the second?
Address.
So it's like a pointer?
Yeah, it's a pointer.
I had this explained to me at one point that it was like what the thing is and the arrow pointing to the next thing.
Yep.
It was
Okay.
Yes.
it was value and arrow.
Yes. So you three are going to be my test dummies, all right? In an array, this is how you're organized, all right? You're right next to each other. I know that B is in the first space, the zero space. I know Joe's in the first, and then the limit is in the third. Now, I want you three to do me a favor.
Okay.
Take your right hand and point to the person next to you. All right, I know there's no one there. All right, now they're in a linked list.
Mhm.
All right, yeah, they're still right next to each other, but now it's going, oh, B, where's the next person?
Joe.
Joe, where's the next person? All right, now I need you three to stand up.
my gosh.
And remember your order.
Qualify.
I know, right? This is terrible. All right, Liv, go to the back of the room. Joe, go to up here in the front corner, and B, stay there. This is why a linked list is kind of awesome. Point to the person who you pointed to before. So now, even though B's here, I go, B, where's the next person? Over here. There could be a lot of stuff here, there could be not a lot of stuff here, and it doesn't matter. I know where the next item in the list is, no matter where they are around the room or where they are around memory. So this is why a list can do stuff like this and arrays can't. Arrays have to be Stephen Stockman. Arrays have to be side by side, but now since we're pointing to where we are, it doesn't matter. You guys can sit down. Thank you so much.
No, I'm staying up here now.
Ben, have a seat.
So that means there's probably a speed difference between arrays and lists and chains.
Very big difference. There's also a difference in speed and memory consumption. So arrays are cool and powerful, but 90% of the problems that we're going to solve, lists are where it's at. So make things a bit clearer. See, we can do computer science stuff. It's not that scary. Cool. Now to add stuff to it. Students dot add students dot add Joe, and so forth. Students dot add Liv. We can add, we also have remove. Then we can also access them via their index. So console dot right line students 1. That will give me.
Joe.
Yep. Even though they don't have an order, they do have an order. Because we added them in a certain order, so they do actually have an order.
Right, no matter how you move them.
Yeah. How are we feeling so far?
How do you move them?
Remove?
Move them. So it doesn't matter the order. They're in order here. Where
Yeah.
would they not be in order?
If you want to like sort them or something like that. Even though we added them in like 1, 2, 3, that's the order that you're actually sitting right here. If you wanted to change the order, you just swap the variables out. Like if you and B wanted, or you and B, if you and Liv wanted to switch seats, it would be just like how we swapped it for the deck of cards shuffling example. Students 0, students 0 equals student 1 equals student 2, and then students 2 equals 10. We just swap it just like we would any other piece of data. So we can access them and update them using the sort bracket syntax.
Can you add later, like let's say we
Yeah.
make our 3 and then we write a couple functions, we do some other stuff, and then we
Students
realize we can add another.
Add Hector, students dot add Amanda. We'll snake it back around.
And it keeps that order.
Yep.
So Hector's 3, Amanda's 4.
Yep, it keeps running. Just like push would keep on adding onto the back. This does the exact same thing.
Did you say if it was 0 indexed?
Yep.
Okay.
Everything is 0 indexed.
Okay.
And gold star if you can figure out why.
Because somebody made it that way.
Yeah, but why?
Because they wanted to.
Okay. That's not the right answer, but I'll accept that.
Is the right answer because they were frustrated by the few things that are one index and they're like, you stick this off by one error,
Nope.
we're gonna solve it?
Nope.
This is binary.
Nope.
No?
It actually comes down to like memory management. Anyway, if you remind me at the end of the lecture, I'll tell you. Unless someone figures it out. So lists are kind of cool. Lists are awesome, right? Really, it's the first case of us using our what's called the generic syntax. That's this thing right here. We're saying, hey, create for me a new list, and it's going to be of type string. So if I wanted to make a type of your var scores can be new list of integers. And it works the exact same way. This just says, hey, we're making a bucket. That bucket inherently doesn't care about what's inside of it. The actions still work. Add, remove, updates, all those things still work on that thing the exact same way. It's just what's inside of it. Because we're defining it, so later down the line, I can't do students.add 100 and 1001. I'm going to nice little error message saying, oh, sorry.
These are integers.
Right. I'm trying to add an integer to a string. I can't do that. Unless you tell me how to do it.
Convert it to string.
And that'll work now. Yeah. So I have to tell the extra step, say, you know what, okay, 1001, I actually want to teach them. That's actually the name of a student. Sure, you know, good old 1001, it's like sitting back in the classroom. No. No, I have to do a little extra conversion because we're telling when we first created it that strings matter. That this has to be a string.
Could you also end run it by just putting 1001 in quotes?
Quotes, yeah. Because if we wrap it in quotes,
It's a string.
Yeah.
Just making sure that's still true.
Can we replace in the alligators with objects? You just say object for a list of objects.
Right here
Int, yeah.
or right here.
Or
So like,
for objects.
just to show what that will do, we're saying, hey, you know what? This is a list of strings, but really, Joe came up with the idea. Why don't we make a list of objects? Just make a bucket that takes everything. Will that work? Absolutely.
Looks okay.
Awesome.
Should you do this?
No.
No.
It's not your first, second, or third choice. Maybe your fourth choice, but it is a thing.
It depends on the use case.
Yeah, it depends on the
Like
use case.
If you run through the first three.
Yes.
And that will probably take up a lot of memory.
It does a lot of, like, once we add this into our thing, we've actually lost its type.
Right.
So if we try to access it, we don't know what it is on the other side.
Right.
I've put it now in a box that says, you know what, this is just, yeah, it was an integer, but now it's just an object.
It's just
Yeah.
Just-
It's like wrapping gifts for the holidays. If I buy you a book, Joe,
Yeah.
I'm going to put it in a box, and I'm going to wrap it, and then what am I giving you?
Box.
Exactly. I'm not giving you a book, I'm giving you a box. So now Joe has to figure out how to convert that box to a book. He has to open it and be like, what is this? Oh, it's a book. I can open it and read it. I know that sounds weird saying that out loud, but it's the exact same thing here. We're losing its type information, but we can store anything inside of it now, which is kind of cool.
Can you just ask it what it is though?
Yeah, you have to do try parse, you have to try to convert. Yeah, I know.
Don't worry.
No bueno.
Is that the difference between parse and try parse? Try parse is when you're not sure if it's supposed to come out of an integer?
Mm-hmm.
That's cool.
So we'll just do a quick 30-second sidebar on that because we have the time, I think. Yeah, sure. Last night, a few of you, sidebar for parse versus side parse, or try parse. A few of you tried to parse integers, right?
Yes.
So parsing integers is how we go from a string to a number.
Right.
So let's say we have a number, or a number as string, equals, what's someone's favorite number?
13.
13, cool. I think there's 21 in there too. We use that one next. 13 is now a string, right? But we know that as a number. So what we can do number as an int equals int.parse number as string. Right? So we know this is going to work, right? But what if var input console.readline? Then we do var number equals int.parse input. If I type in a number, it'll work, right? That's awesome.
But if
It'll
you
work.
type in an address
But
or a name,
yeah, if I type in anything that's not a number, and we have to assume users will because users are dumb, as we learned in the first 6 weeks, they're dumb, it will crash, just straight up crash. We'll see the error just so we can see it. That's because try parse is already assuming that you've already done validation to make sure that, parse is doing all of these things, going, hey, you know what? I'm trusting you that this is a number. So if I try to type in hello, I'm going to get this nice pretty error. And a message saying that it broke it.
Oh.
I'm sure you got that a lot last night too.
Actually, no.
No.
Wow.
No.
Bravo. That's just saying that your program crashed.
Fun.
Yeah, right? Fun. Terrible.
I need some marker.
None of that came out in red though. I got lots of things in red last night.
That's a
I'm
called
just
marker.
impressed your errors and like deleting all of them.
Mhm.
We need to get a picture of your face.
So yeah, we got that stuff. This is where try parse comes into play. Try parse says, you know what, I'm going to try to convert it, but really the syntax is a bit different. Try parse doesn't actually return a number. What? It returns, if we look at its documentation, it returns a Boolean, whether it worked or not, but it also takes what's called an out parameter. We haven't talked about out parameters or functions yet. But it pretty much says, you know what? Was number, out int number. Whew.
That's a lot.
What
This is a lot. Yeah, so let's break this down real fast.
Nice.
Right? So we're saying, hey, I'm declaring a variable called was number, and that'll be a true or false value. It's going to be a Boolean, because try parse returns whether it worked or not.
I used that last time.
Yeah. And then input is the string that we want to try to convert. And if it was successful, we're going to store it in a variable called number.
If it's not, it's just
If it's
false.
if it doesn't work, that's returned false, and our program doesn't crash.
Useful.
It is. Because now we can do like a while loop or like an if statement. Like if not was number, write out that wasn't a number, try again. And you can wrap that in like a while loop and some for logic there to actually say, you know, to make sure that it is a number. Man, do you have a question?
You did.
Oh, okay. Yeah, so now whenever I do this, I can go, hey, I type in hello again, that wasn't a number. So yeah, this pattern of an out parameter isn't really common, or it's not really a thing anymore, because we should just return an object that has the different properties. But it's a thing. It's a legacy thing from C++. I'll just be honest.
Yeah, it sure seems like it.
Yeah, right? The syntax is a bit jarring because now I'm declaring something in a function call. But it's not really doing anything too scary. Cool. So that's in parse and try parse. Yeah. That's how we go from a string to an integer. There's also double and float and decimal dot parse as well. It does and behaves the exact same way. Except we get back, of course, the different types. Back to arrays. Back to lists. So not only can we do simple types, primitives like integers, stuff like that, but we can also do classes. So if I had var collections of new list of yarn, that would work. And I can actually do collection. I'm going to rename you collection. Collection.add wool. And what else do we have up top? Sock.
And that works because yarn is an object.
Yep, because yarn is a class, and you can almost think of classes as custom types. Almost. We're saying, you know what, everything that's inside of this bucket is going to be of type yarn. How are we feeling so far? Amanda, then
Can we map over a list?
what?
Can we map over a list?
We can map over a list. after Hector's question.
That sounds cool.
Oh,
I want to map over this.
cool. We want to map it. So what does map do again?
For each item in the list, we do whatever we write inside the function for map.
So we could do, so we just want to iterate over a list. So as we saw yesterday, we do have our, the for loops. Yay. We can do for I collection dot count. That's the same thing as our for loop over dot length. That should feel kind of comfortable. It's not length, it's dot count.
Oh, okay.
Great.
Terrible, right? And then we could do a for each loop. For each yarn in collection. Oh, okay. That's easy enough. We need something. This is like the dot for each method, right? That we had in JavaScript. So okay, for each thing inside of my collection, do this. I just happened to name it collection by accident. Total coincidence. Those are fine and dandy. Those are fun. That's fine. But we want map, right? We want something that's a bit more powerful. We want to use our dot syntax. We want to be cool developers, right? Well, actually in C#, our map is actually not called map. Brace yourself. It's called select.
What?
What?
Which seems maybe more obvious.
It is a bit more obvious.
Is it?
It is.
Is it?
So if I wanted to select all the wool types or the yarn types that I have, equals yarn.select, and I'm going to get an error here. Yarn dot, what do I call it? Fiber type. I'm going to get an error here because I'm missing a namespace. The namespace we're missing is system.link. Link is a really cool feature of C#. What this allows us to do, this allows us to operate with select or our map, filter, reduce, and a whole suite of other functions on a list. Not just a list, but any sort of IEnumerable, so any sort of collection of data.
Databases and sorry.
Yeah, that's the big thing, is that now we can use these methods, our selects, when we get to filters, our wheres, something that not only on lists and arrays in memory, but also eventually databases as well. So you know how we wrote queries on Monday? We can actually take our link statements, which are just our select, which is just our maps, and it'll convert those into SQL queries for us.
So we don't have to write any more database entries.
It's all C#.
It's gonna do it for us.
Yes. But we still need to know the underlying concepts. We still have to know like what a select statement is, what an update statement is, what a delete statement is. Yeah. So Amanda?
So then like select and where and those things aren't inherent to C#, they're a thing we have to add in with
Yes.
system link?
Yes.
So is that like a library on top of
It's a
C#?
library that comes inside of C#. So it was added to the language around 2010, 10-ish? Version 3, whenever that came out.
It was huge.
It was big. It was the first of its kind. It was like, oh, we can actually do powerful database queries against our arrays and lists and memories, and we can use array logic against databases.
Not everybody was happy.
What? What is this?
People don't like databases.
Because
Well,
not only is it databases, it's any sort of list object. So like a JSON list, a XML collection, an HTML page, a CSV files. So yeah. Dante?
Did you say that they're coming out with a new version of C# soon?
C# 8 is coming out.
8?
Yes.
And when is that?
Whenever .NET 3 comes out.
Okay, so that's soon then.
Very soon, yeah. Very soon.
That's good.
Mm-hmm.
Seems like it needs that.
There's a couple of really cool features I'm really excited for. I think I might have already geeked out over that with y'all once. But yeah, so select is like map. So you can take my list of objects and can do something to each one. It works the exact same way. It takes a function, New syntax though in C#, but familiar to us in JavaScript, right? It's just an arrow function. Pretty much the same rules. One parameter, no parentheses, arrow, do something.
Did you already add the using?
Yeah, I just clicked the light bulb.
That's all you have to do?
Yeah. If I undo it, see the light bulb?
How'd you do it?
How did I undo it?
Yeah.
I hit undo, Control Z.
Oh, duh. Okay.
And then I click the light bulb, and it's like, oh, you want to be using link.
Oh, okay.
So it's
So
just
you click
everything
that,
down.
it automatically fixes it
Puts
for you.
everything down
So then
on.
system links up at the top.
Yep.
Wow.
So is it, we can't use system link on like code katas?
You have to use it.
Oh, you actually use it.
Ooh.
Yeah, right. Just to go down the list, filter is now aware. Var. What do yarns have?
Can we see what that outputs?
Yeah, we will. Skein length. Skein length? Skein length. We'll see what that outputs in cyclic. Actually, let's do it right now. For each item in yarn types, we want to write the item. So let's just see what that looks like. We should get wool and acrylic.
Joe?
And Joe.
Hey.
Joe's our favorite type of wool.
Yes. I can. Yes.
So it's taking our objects and reducing them down to strings. Mapping them to strings. Or, another way to look at it, it's taking our objects and selecting the type. So it's plucking the type out.
And where do you get Joe from? I mean,
Oh, Joe's probably...
There was
I was
a
right
right line earlier.
in the array.
He's in the array now.
right here.
He's student one.
Oh, console.log that out. Yeah, comment. Comments are 2 slashes if we haven't noticed. Just making sure. And then if we want to do our wheres, so var long yarns is collections dot where yarn dot scheme length. What's a long length?
800 yards.
This will give us any of our yarns that are over 800. Cool. Like filter, right?
So when you do the where, the first part is the yarn, that's the object you're calling, and then you're saying, okay, give me this property, that's what that,
Yeah.
and
This
then that is the property, that's the property.
Yeah. This is each item. This represents each item as we go.
Mm-hmm.
And this is what logic we have. So like here it's saying, you know what, return to me just this one thing. So return to me a string of something.
Right.
And remember, our wheres, just like our filters, return a Boolean value.
Right.
And it'll populate that end list with whatever's true value.
That is cool.
And if we look at what the type is, it's an IEnumerable of yarns. A list of yarns. For today, anywhere where you see IEnumerable, just replace it with list.
For today.
For today, until I tell you otherwise.
Great.
Wherever you see what?
IEnumerable.
Internet Explorer.
So you can think of that as a list. How we all feeling? It's a lot. Totally confused, Dante?
Yeah, I mean, I get it, I just don't, it seems so unnecessary.
What's so unnecessary about it? Let's chat about this.
This is very, like, particular and, like, mean.
It's
Yes.
not sticky yet. It's like this
Angry
idea is like a
code.
balloon I'm holding
Yeah,
onto.
it's just mean.
And I have to make sure I hold on to it. Because it'll fly away.
Mhm.
It's No.
It's a new idea.
It is a new
No,
idea.
no, I was hating yesterday. I don't know. I love it when it works, but I hated it every other moment besides that. So it's like 90% hate, 10% joy that I have to be done.
It's just different because like JavaScript is so forgiving and this is like so like you have to do everything.
Yeah, I'm glad we started on
It is.
JavaScript because that's like, it helps
Yeah.
ease into that.
Yeah, and isn't the reason this is more strict because this code is going to be running on a server
Mhm.
versus running on a client. So when you
Right.
run on a client, you have a lot more flexibility. Running on a server, it has to be strict because you could crash a lot of other systems. So that's why they force
Yeah,
you
this
to allocate
is-
your memory before you.
This is
stuff
one
like
of those things where it's like this strictness of what's going on helps us, the developer, even though it's a little bit more work, a little bit extra. Oh no, it's mean to me because it asks me to do this extra step for me. But what it's doing is that my code is going to be guaranteed more correct.
Actually,
I was gonna say, like, it's nice you don't have to save this and go over to local host 3000 and run it and see if it works. Like, you know before you hit terminal whether or not this is gonna work.
You notice I've only run this like twice,
Right.
And it's
Yeah.
worked out every time. After I got rid of all the mumbo jumbo of compiler errors and semicolons, so like I know it works without even running it. I'm not saying it's not going to be bug free.
Not that you could get it to like,
Yeah,
not that you could get it to compile to know that,
yeah, like I said, that's the reason I like it. I mean, it now getting your code up and running sometimes is painful because you'll put something in and it just doesn't work, or you run it like I ran a restriction with arrays where I'm trying to import things and I didn't understand that at first I didn't understand arrays were fixed. And I'm getting errors, you're bringing in too many items and so on and so forth. But once I got it working, once I found the syntax, boom, it was up.
Mhm.
And that's the difference. I think that, for me, from my perspective, that's the difference between this and JavaScript. JavaScript, I think, is working, and then it goes in, and then it's not working.
Yeah.
And I don't know why, and I'm confused. Whereas this, for me, it's straightforward to me, even though it's a lot more.
Yeah. It's a lot more verbose, but that verbosity really helps.
But it's easy to understand.
Yeah.
It's straightforward.
Yeah, I think to me,
It has to be.
Because it's talking directly to databases,
Yeah.
and they don't do something.
And remember, this thing is dumb. Like, as much as we give it like props for being really fast, it's really dumb. I'm sorry, computer. I love you and all, but you ain't the smartest. So yeah, it's different. Cool. Reduce.
Yeah.
Reduce
Reduce.
var total length equals collection. You're gonna love this word. Aggregate.
Good word.
That's a great word.
So reduces down.
Yeah, reduces replaced by aggregate.
That makes so much more sense than select, because select sounds like it should be filtered.
It does sound like it should be.
select
filtered.
sounds
I
like
don't like
query
the
selector.
select and where I see that they came from SQL commands, right?
Yes. Yep.
Aggregate, is that a SQL command as well?
It is actually. I
It
like
is?
Yeah.
Oh man, you're decoding the code.
Yeah. You'll probably notice that select and where are very much SQL, right?
Yeah, they're
Link is inspired by SQL.
That's amazing.
I know. So start on at 0. You want to say, you know what? We have our accumulator in yarn. We want to args,
Arg.
like a pirate. Total in yarn. We want to do yarn dot plus total.
The 0 is the index?
Yep.
you said? Okay.
Decimal to int. Oh, you're decimal. 0.0. Double, and then it is typing is terrible. And then it is going to be M for decimal. Yeah. Right? It's kind of.
That means M for decimal.
It's
I was
not
good
how
until
that
you
should
said,
go.
as soon as you said M for decimal, boom, I was gone. Okay.
So let's unwind what just happened here.
You know.
You don't ever get to write children's books, is what happens.
So what happened here is that we're like, oh, we just want to sum up the total length, right? Nothing too crazy. We know how to do that. We can use a reduce to take a list of objects and create one thing. Take our fruit bowl and create a fruit salad. right? We want to start at 0, right here. We want to say every time we hit something, add something to that total. We made scheme length a decimal, right?
Yeah.
But 0 by itself is a integer.
Right.
So we need to say, you know what? That 0 is actually a decimal. And the reason why it's M for decimal and not D for decimal,
Or C for decimal.
yeah, right? D is a, over this, it's a double.
Mm.
So I can convert numbers just by doing that. D is for decimal, F is for float, and M is for decimal. Mole. There's an M in there, I swear. So yeah, that's it. It's that more explicitness of what's going on. I know, really bites you in the butt sometimes. I'm not going to lie. But now I know that, hey, you know what? It's all going to be, I'm not losing any precision there. Because remember last night in your homework, what's 101 divided by 2?
50.
Not 50.5 like we expect to do, it's 50. The types matter. So as long as we stay all in the same type family, we're good. And this will help enforce that.
Do we all just look like, all right, we'll believe you this far? Like,
Yeah,
yeah, like you're
Yeah.
a bit nice but fine.
yeah, you're like, we get this. I think the balloon analogy was a really good one. You're all holding on to the balloon right now.
And you're declaring total there, that first one.
Yeah.
And then you're gathering that and then adding it to.
Yep.
That's my question. Like, it's literally-
Oh, that's looping through.
Yeah.
So that first, it's the first one you got, and then that total
First one's,
adding
yeah,
it.
yep.
Accumulator.
Yeah, it's the accumulator.
Oh, all right. Thank you, Joe. That's awesome.
You're welcome, man. I'm right in front of you if you need me.
Okay, cool.
Be here all day.
And that's 4-H, so that's
Yeah.
cool. Alright.
There's probably a dozen other link statements that we'll cover over the next couple of weeks, probably tomorrow, to help us help out whenever we work with SQL and C# tomorrow. Whew, right? It's okay. Let's talk about homework tonight.
Yeah, that's
Let's.
Right? So your homework.